Hello everyone. In this video, we shall understand what is dispersion and what are the various measures for dispersion. In the previous video, we have seen different measures of central tendency. We have learned about mean, median and mode. These were the measures of central tendency that we have learned. What is mean? It is the average of all the values. Median is the middle value and mode is the most repeated value. So when we have these central measures, usually we use this to represent the entire data. For example, if I have to tell what is the average marks of max for all the students in a classroom, I will take all the max marks. Suppose we have 50 students. We will take max marks of all these 50 students. We will add it and divide by 50 to get the average marks of 50 students. Now based on this, I can say whether the class is all the students of the class, whether they are very good in maths or above average in maths, or they are not that good. So we need to give them few extra classes and all that to improve their marks in maths. For that, we will find out what is the average value. Now sometimes we will not be able to rely upon these central measures. Let us understand this with an example. So I will give three sets of values here. So the first set of value is 7, 8, 9, 10 and 11. Here, what is the mean of these values? Add all the values and divide by 5. We will get 9 as the mean. I'll take another example of 5 values where I'll take 3, 6, 9, 12 and 15. Here also, if I calculate mean, I will get 9. And if I take another set of values where I have 1, 5, 9, 13 and 17. Here also the average is 9 only, mean is 9. Now if I observe for all these things, the values are mean value is 9 itself. But just by knowing mean, we will not know what are the nature of the values or how far they are scattered. Say by this mean, I can only find out what is sum. Sum of all the values is 45. In all these cases, sum of all the values is 45. So that's why we got mean as 9. But how away are the other values from this central value, we will not be able to understand. Now if I have to check the first one, the first set of values, all the values are pretty close to the average value. So this we say that it is a consistent data. So it is consistent data because all values are closely distributed across this mean, around this mean. Now the other two, this is a little farther, how much the values are little more scattered in this case, and in the last case it is very much scattered. See, one student has got, see, let us assume this is marks out of 20, then one student has got just 1 mark and the other student has got 17. So we have a very bad performer and also we have a very good student in the class. Therefore, I cannot rely upon any one particular measure to improve their marks because we have different, the values are towards both the borders, we can say. So this one is more consistent data, so that I can, whatever based on this mean, I can decide what improvement measures or whatever calculations or inferences I want to take. I can go ahead with this. Now same thing happens with median. When I have a middle value, I will not know whether the other values, so in this example if you see for all the three sets, median is also 9 only because middle value is 9. But how much away the other values are with respect to the central value, if I check, then in the first set the values are closely situated around this mean or median, whereas in the other sets it is very farther away. So measures of central tendency sometimes will not be a very reliable measure to take up some important measures, important business decisions or important calculations. So for the calculations, it is difficult to rely. It is difficult to take only relying upon the central measures. So we need to know what are measures of dispersion as well. So how do we know whether the data is consistent or not? For that, we will use measures of dispersion. And what is dispersion? It is scatteredness, means how much the values are scattered around a central value. Now for this also we need to know what is mean, median or mode. So we are going to find out what is the dispersion with reference to mean or with reference to median only. Now using this scatteredness, I will know the other values. First I'll find out what is the central value. Now the other values, are they closely located around this middle value, or are they very far away distributed, very far away scattered around this middle value? So if the values are closely situated, then we say that it is consistent data. If the values are very far away with reference to this central value, then we say that the data is inconsistent. So we cannot take any strong decisions based on such data. So we will not consider such data for either our research purpose or any other analysis, or say any business decision, major decision making situations. If we have, we will not choose this type of data, because we cannot come to a conclusion with this type of data because it is inconsistent, or we can also say it is heterogeneous data, means it has a mixture of all types of values, a very low value and a very high value and middle values also. With that we cannot come to some conclusions, very serious conclusions we cannot take with such data. So to know, we know how to find mean, median or mode. Now which one to take, which set of data to take, depends on whether the values are consistent or not. So that is measured using these measures of dispersion. Now let us see what all different measures we have for dispersion. So the first measure of dispersion is range. It is the highest value minus the lowest value. This gives you the range. So the next measure of dispersion is mean deviation. Mean deviation is a measure which we calculate using mean or median. So the question will be asked, say find out mean deviation for the following set of data using mean, or find the mean deviation from median. So they'll ask you either from mean or median. So we will have to find one central value. It's going to be sometimes mean and sometimes median depending on the question. So we will find out mean deviation, means how much the values are deviated from mean, and we will find out mean of that. So here we will consider both grouped and ungrouped data. So for ungrouped data means we just have a list of values x1 to xn, no frequencies or no repetitions. For ungrouped data, we calculate mean deviation using the formula x minus x bar, modulus of it, add all that, divided by n. So basically we are finding mean of deviations, very easy to remember. So first find a mean. So this x bar, it can be mean or median. So let me take it as a for some average. So a can be mean or median. So for the given set of values, find out mean or median, then find out deviation. So this is called as deviations. From every x value we subtract this central value, we write the deviations, and we are considering modulus of deviation. So we are not going to consider the positive or negative sign, it's just the magnitudes we will take, add all that and then divide by the number of values. This is mean deviation for ungrouped data. For grouped data, where class intervals and frequencies and all given. So for grouped data, we will find out deviations and then we will multiply it with frequencies to find the mean deviation. So mean deviation is equal to this deviations, we will multiply with frequencies, add the products and then divide by total of frequencies, which is nothing but the capital N, total number of values. The next one is the standard deviation. For standard deviation, we have two types of formulas. For ungrouped data, we have two set of formulas here. One is using deviations, the other one is using squares. So let me write both the formulas. The first one is, we will find standard deviation using, first we take squares of all the values divided by number of values, subtracted from mean square. This is one method. The other method is, We will find deviations. Every x value, we will subtract mean from every x value, same as what we did for mean deviation. We will square it. Here it doesn't matter whether we take the absolute value or with sign, because since we are squaring, it is anyways going to become positive. So we will square this deviations, take the sum of it, divide by n and the root. This is for ungrouped data. For grouped data, the same thing, every square must be multiplied with frequency as well. So here also we have two formulas. One is multiply every square with the frequency and then add all the values, minus here also mean square. To find mean, again we would have used frequency and x. And the other formula is multiply frequency with square of deviations. Divide this by total number of frequencies. This is the second formula which uses deviations. We have another important measure called as variance, and variance is square of standard deviation. So find out standard deviation and then square it. Or in other words, without this square root symbol, whatever formula we get, that is variance, and square root of variance is going to give you the standard deviation. So we can write standard deviation is equal to square root of variance. Now all these three measures are used to determine how much the values are away from a central value. Now suppose we have two groups of data, and if one group has values in certain unit and if the other group has values in some other unit or maybe the same unit, suppose I want to compare two groups of data and determine which group to use or which group is better or consistent than the other group, then we make use of coefficients of these dispersions. For every measure of dispersion, we have a corresponding coefficient of that measure as well. So we'll see how to find that. So the first one is coefficient of range. I'll write this coefficient as C. Coefficient of range is given by highest minus lowest value divided by highest value plus lowest value. So this gives coefficient of range. So the next one is coefficient of mean deviation. So this is coefficient of mean deviation, that is given by, so we have already found the mean deviation using the previous formula, and we are going to consider this mean deviation and divide by the average using which this mean deviation was calculated. Say for example, if I have calculated mean deviation using mean, then in the denominator I have to use mean. If I use median, then I have to use median. So here MD is a mean deviation that we have calculated. A is the average used in this formula. Here we have used average, and I told you it can be mean or median, so that we have to write it in the denominator. This is coefficient of mean deviation, and then we have coefficient of standard deviation. So coefficient of standard deviation can be found by dividing standard deviation by mean. This is coefficient of standard deviation. The most important measure for comparing two different set of values is coefficient of variation. So this is the most important one, coefficient of variation denoted as CV. So this is nothing but percentage of coefficient of standard deviation. So coefficient of variation is standard deviation divided by mean into 100. So this gives coefficient of variation. Now if I have two set of data, I will find what is coefficient of variation of the first set, and then I'll find for the second set. The one which has lesser value is supposed to be more consistent than the one with the higher value. So how do we infer, or what is the inference we get from these calculations is, if CV is lesser, then data is consistent or homogeneous. We can say the data is more consistent, or we can say data is more homogeneous. or we can say it is less scattered, because dispersion is a measure of scatteredness. If CV is lesser, it means it is less scattered. If CV is more, then it is more scattered. Then data is more scattered, like our third example that I took, in which one value is 1 and the other one is 17, where it is not a reliable data. Now let us see how to solve questions on these topics. I've taken a question from one of the previous year's question papers of IGNO BCA, Statistical Techniques. So here we have 20 numbers, and we are supposed to find mean, variance and standard deviation for this 20 numbers. And if the largest value in the above set of numbers is changed to 500, to what extent mean and variance get affected? So this is what we are supposed to find here. Now you can see this is ungrouped data. So for ungrouped data, let us solve the first question. What is mean? It is just sum of all the values divided by number of values. That is mean. I'll not write all these values, I'll just add all the 20 values. I have added all these values, it comes to 927, and divided by the total number of values is 20. So that gives 46.35. This is mean. Now after finding mean, let us find variance and standard deviation. So as told earlier, variance is a formula without the square root symbol. Here we have ungrouped data, so we can use any one of these two formulas. Without the square root symbol, we can find out what is variance, and then with square root, it is going to be standard deviation. Now which formula to use in these two? So either we can find deviations, because we already have mean now, mean is ready. So using this mean, we can find deviations, square the deviations and then divide by n, or square the given values, add all of them, divide by n, and then subtract mean square. Both the formulas we can use. I will choose to use this formula for this particular question, because mean is having decimal values. Mean is 46.35. So if I decide to take deviations, then all the values I need to subtract this 46.35 from all these values. So I have to write 12 minus 46.35, 41 minus 46.35. Those are all deviations. Then those deviations needs to be squared, which is going to be difficult. So I'm not going to find deviations. I'll use the first formula, which has squares. So what is variance? It is sum of squares divided by n minus mean square. So if you observe, I have not written the square root symbol. Now mean is 46.35, we'll square that for this part. Here sum of x square by n means all these values I need to square and add. So 12 square plus 41 square plus 48 square. So all the numbers I need to square it and then add them. So let us find out what is the square of all these numbers. Sum of all these squares, we will get 5273, divide by the number of values is 20, minus mean square, which is 46.35 square. So this is going to be 2513.65 minus 46.35 square is 2148.3225. I will write 32. We get 365.33, and this is the variance. We can also write it as sigma square. Now let us find standard deviation. Standard deviation is square root of variance, which is square root of 365.33, and root of that is going to be 19.11. So this is the standard deviation. So this is the answer for the first question. This is ungrouped data. We have added all the values, divide by n to get mean. We've squared all the given values, added it, and divide by n minus mean square gives variance. Square root of that gives standard deviation. Next we'll see the second question, that is if the largest value in the above set of numbers is changed to 500, what happens to mean and variance? So to understand this, we need not change all the values, just change one of the value. So here, what is the largest value among this set? The largest value is 79. right? Yes. So the largest value is 79. So what is the largest value? Which is 79, and it should be replaced by 500, right? Largest value is to be replaced by 500. Now what is mean? So to find mean, we will take sum of all the values divided by the number of values, right? So sum of all the values, we know it is 927. Sum of all the values divided by number of values. Sum of all the values is 927. Considering this 79 as one of the value. Now in that 20 values, I am removing 79 and I am adding 500. So remove 79 and then add 500. Now you divide this total of all the values by 20 to get the mean. So 927 minus 79 plus 500 gives you 1348. That one divided by 20 gives 67.4. Now we will find variance as well. So what is variance? To find variance, I need to first know sum of squares, right? Sum of squares by n divided by mean square. Now, what is sum of squares? Earlier I have already found what is sum of squares, which is 50 to 73. So in this 50 to 73, this includes 79 square. I need to remove 79 square and I need to add 500 square. Since this is sum of squares, 79 square should be removed, new value is 500, that square should be added and then divided by 20 minus mean I have already found, which is 67.4. I am going to take square of this, which is 294032 divided by 20 minus 4542.76. We'll find what is the answer here. We get 10158.84. So variance and mean increases a lot. It is because all the values are 2-digit numbers and are very small values, whereas the number that we are replacing is 500, which is going to be a very, very high value compared to all this. Because of this high value, mean is also increasing. Earlier it was 46.35, now it is becoming 67.4. Variance is also increasing to a great extent because it is 365.33 earlier and now it is 10158.84. So this is a solution for ungrouped data. Now we will see how to solve a question with grouped data. So here I have mean and standard deviation we are supposed to find for grouped data. Here we have class intervals and frequencies given. So this is class interval and this is frequency. I'll continue here itself. So this is class interval. Number of students is nothing but the frequency. Here I need to write the midpoint of all these values, which is x values. For all these class intervals, I am going to write the midpoint. So what is 0 to 10 midpoint is 5. Here it is 15, 25, 35, 45, 55 and 65. So class interval is given. First we will write x values. Now I need to find what is mean and standard deviation. So first write down the formulas for whatever is required. Mean is, this is grouped data, right? So for grouped data, it is sum of fx divided by sum of f. So add all these values, that gives sum of f values. Totally we have 100 students here. So total of all the values, frequencies is 100, means we have 100 students. And then we will write fx now, which is product of f and x. So I have multiplied all the frequencies and x values. Now we shall add all these products and we will write what is sum of x values, sum of fx. I have added all the frequencies with the midpoints. So here we have all the products. Now we need to add all these products, which comes to 3790. Now we can find what is mean. So it is 3790 divided by 100, which is 37.9. So this is mean of the given data. Now we need to find standard deviation. So as I told you, either we can take approximately mean as 38, write down deviations and then write the squares. So we can write x minus x bar and then take the squares of this and then multiply frequency with this squares and then take this total. So this way we can write, and I'm not going to find the deviations, I am going to directly take the squares of the value. So that is one way, using our second formula which involves deviations. The other one is this x values itself I'll square. Square of x values we will write, then multiply frequency with x square values, add these values to get summation of fx square. This we can use it in the standard deviation formula. So now first let us write the squares of x values. So this is 25, this is 225, 625, 1225, 2025, 3025 and then 4225. So if a number is ending with 5, then finding square of that is very easy. So if I have 65 square, then take the first digit and multiply it with its next number, which is 6 into 7 is 42, and then in the end you write 25. Any number, if it's 35 square, for 3 the next number is 4, so 3 into 4 is 12, and then 5 square is 25 in the end. So any number that ends with 5, if you have to write the square, this is how you can write quickly without using calculator. So if you have 75 square, then 7 into 8 is 56, end it with 25. So that is squares of 2-digit numbers. More such shortcuts I have explained in the aptitude videos, that is also part of the channel. If you are interested, you can go through them. Now I have all the x square values. Now I am going to multiply these frequencies with this x square values and we shall write it here. Now I have multiplied frequencies with all the x square values. Now we are supposed to add all these products, which comes to 170,300. Now we shall find what is standard deviation. So what is the formula for standard deviation? It is sum of frequency into x square divided by sum of frequency minus mean square. The first formula only I am using. So this we have found, which is 170,300 divided by the total of frequencies is 100 minus mean square, that is 7.9 square, and root of it, which is, this zeros gets cancelled, we have 1703 minus 37.9 square is 1436.41. Root of this 16.327 is what we will get. We will take it as 16.33. So what is standard deviation for the given set of data? It is 16.33. So this is how we find the standard deviation for a set of group data given with class intervals and the frequencies. Hope it is clear, and these are the questions asked in previous exams of IGNOU BCA. I am sure even for the other universities the questions are going to look similar, and I will be also posting some of the notes which has questions and the solutions only. Here I have explained the procedure. More such examples videos also I'll post, and also I'll share the notes in the Telegram channel. So if you have not yet joined, there is a link in the description, you can join, and if you have liked this, share it with your classmates. See you in the next video. Bye bye.